Hi, welcome to the Applied Data Science course for beginners. This is the syllabus of the course. In this tutorial, we will focus on theoretical part of one of the popular machine learning algorithm, decision tree classifier. First, I will discuss introduction about decision tree classifier, then I will introduce some terminologies. After that, intuition behind the algorithm and selection measure. And finally, I will demonstrate the example in order to understand the decision tree algorithm better. Decision tree algorithm is known as CART, classification and regression trees introduced by Leo Breiman. Decision tree builds a tree based on the information and therefore uses a tree structure and their possible combinations to solve a classification or regression problem. CART algorithm is a foundation for other important algorithms, such as Bayesian decision trees, random forest, and boosting decision trees. These are the algorithms we will discuss in the later videos. In this tutorial, we will focus on a decision tree classifier only. This is what a decision tree structure looks like. We can see a node which is further split into other decision nodes, and they are also divided into subnodes until they reach leaf nodes. Here are some terminologies. Root node represents entire sample which is divided into two or more sets. Splitting is a process of dividing a node into two or more subnodes. Decision node is called a node when a subnode can be split into further subnodes. Leaf node are nodes that do not split anymore. Pruning is the opposite action of splitting, which tries to remove subnodes from a decision node. Subtree or branch is some part of a tree shown in the black rounded box above. And finally, parent node is any node which can be divided into subnodes, whereas subnodes are children of parent nodes. What is the intuition behind the decision tree algorithm? First, each attribute in our dataset forms a node, and most important node is placed at the root node. Then we do splitting based on some selection measure, and this process is continuous until maximum depth is reached or tree forms a leaf nodes. But wait a minute, what are the selection measure? How can we split the data into subnodes? There are different attribute selection measures. In this tutorial, we will focus on Gini impurity, also called Gini index, because it is used in CART algorithm. Gini index has the formula 1 minus summation of pi squared, where pi is the probability of a particular element belonging to a specific class. Things to remember. Gini index is always between 0 and 1. If Gini index is 0, this means that the division is pure. So all the elements are correctly divided into different classes, which is the ideal scenario. Whereas if Gini index equals to 1, it means that elements are randomly distributed across classes. Don't worry if you don't understand the definitions quite well. Now we will have an example of it so you will understand it better. Imagine we have a toy dataset about wine shown above. There are three features. Alcohol and density are input features, whereas quality is output feature, also called ground truth label, which represents whether a wine is a good quality or not. Also, we have a scatter dot visualization next to our dataset, where orange dots are good quality wines and blue dots are bad quality wines. In order to create a tree, based on this information, we need to start splitting the data. But how do we choose a good split? The solution to this question is to split the data multiple times and then choose the best split based on the criteria. Let's have a first split when density equals to 4.5. In this case, as you can see in the visualization, the data is separated into two parts, and one part contains 3 orange and 2 blue dots. Another part contains 3 blue and 2 orange dots. Is it a good split? In order to answer the question, we need to do some other splits as well. Let's do a second split. In this case, we have 4 orange in one part and 5 blue and 1 orange dots in the second part. In the same way, we can do the third split, and in the third split, we can see that the threshold separated dots in a best way. Blue and orange dots are separated perfectly. In your opinion, which is the best split? Right, the third split is the best split because it separated the classes perfectly. But when the dataset is too huge, we cannot visualize all the splits. Here is where a Gini index comes in. We need to calculate Gini index of each split, and let's pay attention what we will get. First split was when density is greater than 4.5, and let's calculate Gini index of this split. In order to do that, split the data into two parts. In the left part, we have 2 blue and 3 orange dots. In other words, 2 good quality wine and 3 bad quality wine. In the right, we have 3 blue and 2 orange. We calculate Gini index of each part. Gini left equals to 1 minus 2 over 5 squared plus 3 over 5 squared, because we have 2 out of 5 blue and 3 out of 5 orange dots. We can do the same technique in the right node as well. Final Gini index of this split is calculated as weighted sum of two indexes, which will be 5 over 10, because we have 5 out of 10 in the left side, multiplied by 0.48 plus 5 over 10 multiplied 0.48. And we will get 0.48, which is the Gini index of the first split. Let's do the same calculation in the second and third split. In the second split, we have alcohol is greater than 6.5. In the left side, we will have 0 blue and 4 orange, whereas in the right hand side, we will have 5 blue and 1 orange. If we calculate the Gini index in the left and the right side, we will get 0 in the left and 0.28 in the right. And final Gini index is weighted sum as mentioned, so it will be 4 over 10, because we have 4 dots in the left side multiplied by 10 plus 6 divided by 10 multiplied by 0.28. So final result will be 0.078. Let's do the same calculation in the third split. In the third split, we have alcohol is greater than 5.5. In the same way, we have 0 blue and 5 orange in the left and 5 blue and 0 orange in the right side. Gini index is 0 in both sides, and final Gini index is 0 as well. Here is the split and their Gini indexes. As a reminder, the best split is the one which has the lowest Gini index. It's not surprising that the third split is the best one. This is how we choose the split. This is the end of the tutorial. I hope you liked it. To sum up, we have discussed introduction to decision tree classifier. We've learned its terminologies as well as intuition behind the algorithm. Using the example, we've demonstrated how selection method such as Gini index works. In the next tutorial, we'll do practice of decision tree by building a project using Sonar dataset, which involves the prediction of whether an object is a mine or not. Make sure you subscribe in order not to miss it. See you in the next video.